Okay, and then going to share the screen. Okay, let me find my book. Okay, this one. Yeah. So everybody can see my screen, is it? And I remember last class, we discussed you merge a couple of data frames together, is it? And the last class we learned with the concat method. And there are two other methods you can achieve similar similar results. Okay, one is called join. Okay, so let's see. And for join, why I do the annotation? Why the annotation not working? Okay, why is the join method? And for join over here on my books, on my notes, it says you can do the nature join. Nature join is inner join. So look for the intersection. And we also have outer join, and you can specify as outer. It's kind of like union, is it? And you can also specify left out join, then specify as how, and right out join how as right. Okay, so let's take a look at examples. How do we do all of this? The first, so here we have two very simple data frame. The first called left, that's how it looks like. Is that two column, is it key and value? And index, one level of index, that's called left. And for right, it's similar, is it? And then over here, we call merge. Okay, so first let's discuss the merge. So we use the merge method to merge the left and the right. Okay, so let's take a close look. And you also specify when you merge on which column, is it? So here it's specify on the key column, is it on the key column? And if you don't specify anything by default, it's nature join, is it a nature join? Okay, so over here, is it, so it, if you take a close look, the key, it all has fulls, is it? And with different index, is it? And the left has the left value, is it? And the right has the right value, is it? So after we do the merge, the result is going to look like this. Okay, so this is the first one, merge, and you specify key, okay? Then let's take a look at the second case. The second case, left and right, a little bit different this time. It has, the key has two values, is it full and bar, and the corresponding left and right value, is it? And then it do the merge, and the merge on what? Also merge on key, is it? So it's merges on the common of this key. So this is the second. Then let's take a look at the third one. The third one, the first is dictionary. Dictionary have two dictionaries, and then we convert them to data frame. So nothing new here, is it? And we can see the two data frame, is it? And so these are the two data frame you formed from dictionary, is it? And then we call merge, is it? And this time you specify the merge on two columns, is it? Key and key one, is it? On both of this. And previously we said it's nature or join, is it? Nature join. And nature join, basically it's inner. By default, it's inner, is it? And the inner looks for what? Looks for the common things on what you specify, is it? So here I say, oh, this has key zero. So this is the same, is it? And then what's next? K2 and K0, K2 and K0, is it? That's how you have this result, is it? Because you have, so inner is intersection, it's the commons from both data frames, is it? But it adds this new columns, is it, on top of the DF's columns, is it? So that's what the merge means, okay? And then you can see here. Here we do the same thing on those two data frame and still on the same key, but here specify the how is on what? It's left. Left is left outer join. Okay, left outer. So it pick all of the columns here you specify, is it from this guy? So this is the left. Okay, so that's how over here basically we keep all the columns, is it from DF? Is it the first data frame? And then next, let's see. The next one, same thing, you do the merge outer. The how is outer. Outer is union, is it? So it's include everyone, is it? So that's why you include all of the keys from both DF and DF1, is it? And then you expand the columns, okay? So this is pretty straightforward. And the next one is similar as DF there, and you can also specify how as inner. Inner is intersection. So also nothing very specific here. And then next, let's see. So previously showed merge, is it? So this is the second method. You can find concat, as it is what we learned before. And the next is join. Is it join? So let's see. So here, same thing. We have two dictionary, is it? And you use dictionary to form the data frame, and you also specify the index, is it? And we know of this. And then let's see here. When you do join, and it's called DF. So the first data frame, then dot join the second data frame. Okay, so what the result will look like? Then let's see. So here is DF. So DF and DF1, is it? So we have these two data frame, and then you call DF dot join DF1. So DF1 join on DF, is it? And what the have in common, is it, is what is K, the common, like what we previous K0, is it, and K2, and K2. But here, because it's DF1, join DF, okay, join DF. So this kind of like the left join. Okay, the left join. Okay, so basically, if you take a look at the result, you will find it didn't look for like the common index. Is it what it looks for? It's just purely on the left ones, because this is the DF. Is it DF? So then it combine all of the columns. Is it? But it use DF's index, is it? And of course, some value it doesn't have, is it, like prints, is it K1? K1 in DF1, it doesn't have K1, is it? So that's how the address and the qualification it filled just with the nav values, okay? But it's based on DF, okay? So just be careful. It's kind of like the left join, is it? Okay, and over here, you can also do specify how as outer. And if you do the outer, then it's the outer join, it's a union. So it will include everyone's keys. Okay, so So this is similar as the previous. And then let's see the DF, here we have that two data frame. Is it nothing new here? And they have their corresponding index, is it? And then over here, what is has is for the DF. So this is DF, this is DF1, is it? And DF1, this is index. Is it? For DF, this is index because you didn't specify, is it? But you do have the key column. So key is column here, is it? And you can still do DF like join, is it? And because for the second DF1, you have index here. This index has similar definition as a column key, is it? So if you want to join, then you can specify, okay, on this data frame, which column I want to use, is it, to do the join, is it? Then it will use that to do the join. And if you take a look at the result, then the result is to still keep the key, is it, as a column, but it's expand the columns, is it? And it didn't change DF's index, is it? So the index still keep as DF's, is it? Keeps as DF, so just be careful, okay? Minor things. When you pick which way, you just need to be careful, okay? And what the next one shows, it's similar, is it? But this time we have this kind of thing. We have two dictionary, and then we have data frame. This is the first data frame. The index is specified as K0, K1, K2, is it? And then to give it a name called key, is it? And for the second one, here we call multi-index, so multiple level index. And you're going to form multi-level index. From what? From a tuple, and you specify the tuple, is it? And for these two index, you also give them name, K and Y, is it? And then you build the second data frame, DF1, okay, with this multi-level index, is it? This is multi-index. Multiple level index, is it? And then we do join, is it? And join, and you specify, okay, I'm going to do inner join. So how that's going to work? So let's take a look. This time we have multi-level index, is it? Multi-level index for DF1, is it? And you join, you still do df.join, not df1.join. Okay, you do the df.join. And the join, here you have the index, is it? And for df1, did you see you have two index, is it? So this is one level of index, this is another level of index, is it? And you're going to do inner join, is it? Inner join going to look for what? To look for the common between these two index, is it? Between these two. So it doesn't matter about the other level of index, it will keep that, is it? And then it just expand the columns, okay? So multi-level index, you can also do join, okay? And append rows to data frame, so that's not difficult, is it? Just a kind of like Python's list, is it? We have the append function, is it? So here similar, you just do append, is it? But you append a row, is it? And the row should be some series, is it? Yeah. Okay, the next interesting thing we are going to discuss is about grouping, okay? Is about grouping, okay? So because we have a kind of data frame, is it? Data frame, not like a series, it's homogeneous, it's not so series just one dimensional, is it? The data frame, you have multiple dimension, is it? And then you may have different category, is it? So a lot of times with our data analysis and machine learning is you need to split data into certain category and group, is it, based on some criteria, is it? And then you apply some function to each group, is it? So then you can also combine the result together, is it? So that's how the grouping works. Okay, so let's take a look. So here we have this is dictionary, the dictionary. And you have this dictionary, then you call pandas data frame. You build this data frame. Okay, so here we have this data frame. So nothing new here. And what if, let's take a closer look of the data, is it? So for column A, as a column A, what we have? We have full, we have bar, full, bar, full, bar, full, full. Is it? So looks like under column A, you have full and you have bar. Is it? So here my point is, can we do something? Is it do something and group by either full or bar? Is it for all of our values here? C and D are numerical values here. Column C and column D, is it their numerical values? So is there some way we can organize our data just around the full, around the bar, and find like their summation or the number of items, is it? Or like the maximum, minimum, or the mean value, is it? Do some grouping thing, yeah. Then we can do that, okay? And of course, you can write quite a number of statements to achieve that goal, is it? But in pandas, there is a very easy way to do it. You just call group by function on the data frame. Then you specify which column you want, which category is it you want to do the group by. So here it says group by A, is it? And A we have full and bar, is it? And then you on the group by the result, what you're going to do? Okay, I want to do summation, is it? Total, the summation of all values under full, summation of all of the values under bar, is it? For C and D, is it? So then you see you have this kind of result, is it? So basically for C, for this value, it is what? It's this 0.5, is it? And 0.94 and 0.44, is it? And this one. So all of this going to add together, is it? Then you will have this result, okay? So that's how this works. So you group by and then you do something. And then next, let's see. Over here it says, you can also do group by for hierarchical index, is it? Because over here we have multi-level index, multi-index, is it? A and B, is it? And then you say, okay, I can do group by, I specify for both index A and B, and then I do sum, is it? Then in this case, you see, it's not just for full and by, because under it you also have one. Then you're going to add all of them together, is it? So that's how the group by works. So you can see group by is quite interesting, okay, and useful. Okay, and then for data frame, another useful approach to manipulate is to do reshape. Okay, so reshape is initially you have certain number of index and a certain number of columns, is it? And what a reshape is, you make it fatter, is it? So you extend more columns, so you you move some of the index to column, or you make it skinny, is it more slim, then that means you move some of the columns, is a multi-level, to index, is it? So then let's see, how do we do that? One way is we can through stack. Okay, we call the stack. So let's first take a look here. So here we have a list. So this is a list, is it? And we have another list. So we have two lists. With two lists, then you call zip function. Previously, we learned that, is it? So this can do what? Can do tuples, is it? It will form tuples. So it will form by pair, is it? By pair, is it? So that's why we have the parentheses, is it? And then you get all of the tuples together to a list, is it? So that's what this part means. Okay, then next, let's see. So be very careful, okay? You may see this and what's the difference between this one and the previous one, is it? So let's see. Here you have a list, is it? And then second list. Okay, and then you have the outer brackets, is it? So that means you have list of list, is it two-dimensional, is it? And the two-dimensional, then what you can do, if you add a asterisk, is it? Then you can unpack the outer list. So you get rid of the outer list, is it? So basically what this will give you is the same as the previous cells shows, is it? And then you do zip, then you can pair, okay? Otherwise, you cannot find the pair, okay? So if you have a list, and within the list, you have another list, and if you want to form tuples, is it? Then what's the very first thing you need to do? You need to use asterisk to unpack, okay? After unpack, then you can form the pair, okay, zip. Okay, so this is just a review from what we learned before in Python part. And then next, let's see. So we have the tuples, is it? And then over here it says it's going to build the data frame. This data frame going to use the tuple, the list of tuples, is it? And the column is called first and the second, is it? So this is the tuple, list of tuple, you form the data frame. And here, because you didn't specify index, it's use the default index, okay? So nothing new here. And then next, let's see here. Okay, the multi-index, is it? And from tuple. Previously, we also see that. And in this, then you can create hierarchical index, is it? So you use that tuple that we just created, is it? That's a data frame, is it? And then you can build the multi-level index. Okay, so multi-index. Okay, then let's see this data frame. So this generate an 8x2 data frame, it from random number, is it? And the column, nothing new, it's just A and B. But be careful about the index. Index is through what? It's use this multi-index, is it? It's use a hierarchical, is it? It's use a hierarchical index, is it? So that's the point here, okay? The index is not the single one, is it? It involves two level, is it? You see, it involves two level. Okay, so first and the second is a two level multi-index, okay? And then let's see what do we do, okay? And then you can do slicing, nothing new here, as it is the slicing just as usual, okay? And the interesting thing here, we can also see that's df2, as it. So the data frame DF2 looks something like this, is that you have two level of index and two column, is it? And then let's see, here we have data frame. So this is 2 by 8, is it? And the index is AB. So the multi-level index, the multi-index, the hierarchical, is it the hierarchical one that we just generated? Is it? It can also be applied to column. Okay, column. So here index is just A and B. Is it pretty simple? But for column, did you see you have two level for the column? Okay, you have bar, but under bar you have another two column. Okay, so that just shows. For the hierarchical, can be applied both on index and column, is it? So then next, let's see. So the stack method, okay. So stack can compress a level, okay, in data frames column, okay. So let's see. This is the DF2 column, is it? This is our this is a data frames column. So we have two columns, the first and the second. Okay, so just keep that in mind. And then let's see, over here you call the stack on that data frame, is it? And if you take a look at the result, this is the first level, is it? First level of column. Is a column. And if you take a look, if after you call the stack, what it changes? It changes. So previously we have bar. On the bar we have 1, we have 2, is it? And then under bars, you also have 1 and 2, is it? The column, is it? So now if you take a look, after you call stack, what happens? It kind of rotate 1 and 2 column to index, is it? It kind of move the second to index now, is it? Now under your column, you see, you only have bar, bars, full, and quads. Is it? So it changes the shape. That's why we call it reshape. Is it? Reshape, so make the original table more slim, is it? So that's the stack works. So this is by default, we don't specify by which axis, is it? And then let's see, you can also specify here. So here the specify plug in with 0. 0, that means for the first index, is it? First dimension index, is it? So for the column, so first dimension, yeah. The first dimension, the first dimension is what? You remember previously, first, then second. First is outer, this is the inner one. Is it? For the first, we have the bar, bars, is it? And then we have 1, 2, is it? 1, 2, is it? So over here, you specify 0, it means this level. Okay, so this regarding 0. That's why how it's going to kind of rotate it to index. Okay. So this is stack 0. And if you plug in with 1, then you see, if you plug in with 1, is it? Then it gets the second, is it? So if you don't specify, you remember previous, we don't specify, it's the result looks like this, is it? That's it will go with the most inner one, okay? And what next one shows more interesting, is it? You can also use a list. to specify the dimension, is it to do stack? Here it says, okay, on both 0 and 1 dimension, first 0 and then the second. Is it? And basically you change the data into 1D. Is it one dimensional? Okay, so make it just a column data. Is it? So you can do something also like this, okay? This just shows different ways. Okay, the stack, so we already know this. And then next, let's see. So here we have this data frame called stacked, is it? So it's just a single dimension, is it, data? And what does it mean? How do we reverse back? Is it inversion of stack? It's called unstack. Okay, unstack. Unstack is just whatever the innermost index is. This is the innermost. It will get it to column. Is it? So it get it to column. Is it? So that's unstack. Okay. And you can also specify for which one, is it? And here you specify, said, okay, 1, is it? Y is this one. This is 0, 1, is it? So if you specify for which dimension, is it? Which axis, is it? Then it will go unstack for that specific axis, okay? And the 0, is it? 0 is what we just showed, is it is the outermost one, okay? So that's regarding stack and unstack, okay? And the last part, basically for pandas, okay, is about the pivot table, okay? So pivot table is that allows to do regroup and reshape data, okay? And then to automatically do sort, count, total, average the data stored in the table, okay? So a lot of time, the pivot table is quite useful for you to do some reporting work, okay? To do some summary for the messy table, is it? And you do some kind of summation, okay? So let's see, here we have this data frame formed from a dictionary. So this is our data frame. Is it? So we have default index, and then we have column A, column B, C, D, E, is it? And this is heterogeneous data frame. So you have string, and over here you have numeric. So only these two are numeric data. Is it? ABC string, is it? But if you take a close look, you will find under A you have 1, you have 2, you have 3. Looks like only those 3 word comes. Under B you have ABC, is it? Under C you have full, you had bar, is it? Only 2 category, is it? Okay, so we kind of have some basic idea, is it? And then next, let's see. So if on that data frame, if you call pivot table, the pandas pivot table for that data frame, is it? You need to specify on which column of numeric data you're going to do, okay? So there's some numeric column, is it? And you also specify the index is from which one, is it? Here it says from A and B, is it? A and B is the first 2, is the first 2 column. And then you say, okay, I'm going to use which column as my column? Is it? Here it says, okay, C, is it? C, okay. And what kind of aggregation you're going to do? If you don't specify this one, it by default is going to be mean, okay? So default one is mean, okay? And here I said I'm going to do aggregation with summation and find the number of items for my aggregation length, is it? And if you take a look at the result, And it looks something like this. Is it? So here to specify index, is it the first two A and B? Is it? So it's 1, 2, 3, V, A, V, B, V, C. Is it? And column is based on what? Under C. Is it? So you have bar and foo, bar and foo, bar and foo. Is it? But you're going to do calculation value on what? Only doing value on column D. Is it? That's column D. Okay, column D, you're going to do what? I'm going to do summation. Is it? So this is a summation. Okay, so for all of this category, is it under one, under V1 and under bar total, how many you have, it's going to sum of that. Okay, and it also said, I want to know how many. Is it under each other? And if you take a closer look, you will find it's just one. There are not multiple items. As if we change our table, if you have multiple items here, it may show 2 or 3 or 4, and then it's a summation result. But for some of that, you can see it also doesn't have result. Then it will just report as net. Okay, so this is what this pivot table, how it works. And then next, let's see, we also show something like this. Is it still called pivot table on that? And we still use column D for our numerical, for our aggregation, is it? But this time for index, we only pick A. Is it? For column, we pick C, so bar and foo. And this time, if you take a look, the aggregation, what I'm trying to find is, I'm trying to find under each of the category, the largest number. Is it largest number? Okay, did you see it did report the largest number for each of the category? Is it? So what this returned, from this result, we can see it returns a what? Returns a data frame. Is it? Returns a data frame. So a lot of time after you get the general report, is it? You may want to do some further operation, is it? You may say, okay, for this report, because anyway, this is data frame, I want to find out all of the value who is greater than 0. Is it? Who is greater than 0? And I'm only going to be interested in under the bar column. Is it? Then did you see it automatically give you the result? Is it? Because a lot of time when you do data analysis or machine learning, you're not going to use the whole table, is it? You're going to pick out some data as it meet a certain condition, and maybe you also do some manipulation on the data, is it? And then you do some further operation on that. Then you see you can borrow this kind of concept to do it, okay? Otherwise, if you just write a regular statement, it take probably more than 10 to 20 statements to achieve the goal, is it? But here you can see it's quite simple, is it? You just call the pivot table, is it? And it will automatically do all sorts of aggregations for you, is it? You can also define for the aggregation, you can also define your own function, is it? And then plug it in, is it? Or lambda, is it? So this aggregation, this is also very flexible, okay? You can also define your own one and apply it here. Okay, and what is the next, the last one shows the pivot table. It's similar. It's you can also specify the values, the index, is it, and the column. And here, did you see I didn't specify any of the aggregation. So by default, what it does, it's calculate the means. Okay, calculate. So if you didn't specify them, by default, it's a mean calculation. Okay. And for the remaining time series and everything, for this pandas introduction, we are not going to use it in our machine learning, so we just skip those.